This is the second video on section 7.2, Fubini's theorem. And here we're going to integrate the function x squared y plus 2x minus y over the rectangle 2, 3 cross 1, 2. And so in the last video, we integrated with respect to x first, and I said we could go ahead and integrate with respect to y first. We have a rectangle, so it doesn't matter which order we do that in. And so here I'm going to integrate with respect to y first. So the y interval is 1 to 2, the x interval is 2 to 3. So if we're going to integrate with respect to y first, we put the y limits of integration on the inside, we put the dy on the inside. So we're going to integrate with respect to y first. That means we pretend x is a constant and y is a variable. So we find an antiderivative with respect to y. So we have 1/2 y squared, we have our 2xy, and we have negative 1/2 y squared. We have our limits, our y limits of integration are 1 to 2. We'll calculate that. After we're done with our calculation, then we just have an integral in terms of x. So now what do? We substitute 2 for y, we substitute 1 for y, and we subtract. So that's what we did right here. We just make our substitutions and we subtract, then we simplify. Now we just have a Calc 1 problem, right? We just have a second degree polynomial that we're integrating. So we're integrating from 2 to 3 of 3/2 x squared plus 2x minus 3/2. So we find an antiderivative. Again, this is a Calc 1 problem. We're just using the fundamental theorem of calculus part 2. Find an antiderivative, substitute 3, substitute 2, subtract, simplify.